Welcome to the 27th episode in LastOnlineTuition.com videos. We're discussing chapter 10, the final chapter of C2, and it's entitled Trigonometrical Identities and Simple Equations. We're going to discuss the two identity rules. We're going to then go on to show some examples of how to derive angles from different trigonometrical functions, and then we're going to utilize some simple equations. So the two identities that we're going to highlight here have already been written, and we're going to label this as 1 and we're going to label this as 2. Now this particular equation here is derived from the law of the trigonometrical functions, and this one here is from the equation of a circle, and you have more of an explanation with regards to each one within this particular page. And you have some examples here asking you to simplify the expression. So we'll just go through example 1 very quickly. You can see that this is equal to 1, reason being that the theta has been replaced by 3 theta. We can see for B, all that's happened is the equation has been factorized, and we can notice that there has been a rearrangement of the equation 2 in our particular situation. And it's been simplified to give us the answer as such. And then likewise here we have that the equation is also noted to have a rearrangement of the equation of the circle. So we have this, it's square rooted, and then we can see that we have the first identity represented here with the 2 theta instead of a theta in our particular case. And then again, example 2, another question utilizing or noticing that there's the difference of 2 squares here, in order to allow you to then progress through to find the right hand side from the left hand side and solving this question. Again, just inputting, for example 3, this value into the cos squared theta value, squaring, and then just simplifying, and you have the answer. So these are all examples for you to do. Here method 2 simply utilizes the triangle, the Pythagoras theorem, and your appreciation of the different quadrants, okay, and where they are positive. Remember, a mnemonic way of remembering this is all students take calculus. That's just something that always sticks to people's minds when they're doing mathematics, and it helps to remember where each trigonometric function is positive in its respective quadrant. And again here the same thing, just working with the opposite, the adjacent, and the hypotenuse, appreciating all the lengths using the Pythagoras, and then using the triangle laws, being able to decipher the values that are required. And here you can see all that's happened is just some simple rearrangement, and then the numbers, then the values have been substituted in to the identity here, identity 2, and you can see they've been squared, and then everything has been multiplied by 36 to remove the denominators, which gives us the value, the equation that we have been asked to find in this particular example. And some more examples, exercises for you to play around with. 10.2. So 10.2 discusses the following. It's asking you to note down all the angles, all the points which take place during this range for theta. So for example, when we have sine theta equals a half in the interval 0 is less than or equal to theta, but theta is 0 is less than, theta is less than or equal to, theta is greater than or equal to 0 but less than equal to 360. So we know that sine theta equals a half already from what has been given to us. So when we use sine to the power of -1 or sine inverse, however you want to phrase it, then you can see that theta equals 30. So we know that sine again is positive here in the second quadrant, so we can take this particular diagram and indicate that the next value will be 150, or likewise utilizing one of the properties, which is 180 degrees minus 30 minus theta, in this particular case gives 150. Okay, and this is again using something that we've learned before. Between the interval of x is greater than 0 or less than or equal to 360, we have 5 sine equals minus 2. So we just simply rearrange by dividing 5 on both sides. We get this value, again using the calculator to find out what x will be. So we know that it's minus 23.6 here, which means that we have to take the clockwise root. So we get 23 minus 6. We also know that sine is going to be positive in the second quadrant, but here, because of the fact that we have the negative, we can see that the value is going to end up in the tan or the third quadrant. Okay, and then you can see that we have here the 203.6 value, or to 3 significant figures, 204, or x is going to be 336.4 degrees, or taken to 3 significant values, I have 336. Now, these are the two values for the equation. So you can see that it's going to be 203, and then finally it's going to be another almost complete circle, 336. So essentially what they've done here is they've appreciated it's a negative, okay, and so for that reason you can see it's almost mirror imaged in the x-axis, and then starting from the x coordinate or the theta coordinate in this particular plane, they've then taken 203 and then almost completing a full circle, 336. And here you can see a first solution of the equation sine x equals k in your calculator value. A second solution is also discoverable by using this property. Other solutions are found by adding or subtracting multiples of 360 degrees or 2 pi radians, depending on which you're working with. And then you have another example here. So you can see that this, when input into a calculator, is going to give us x equals 30. So you know that if we have 30 here and cos is again positive at the fourth quadrant, so we have 30 or 330. So 30 here, if we go all the way around again, we have 30 degrees from 360, the complete circle, and again the maximum of our interval, so we have 330. And again it says here the first solution of the equation cos x equals k is your calculator value, okay, of such. A second solution is 360 degrees minus alpha, or 2 pi minus alpha if you're working in radians. And then other solutions can be found by adding or subtracting multiples of 360 or 2 pi radians. And then for sine, you can see now what they've done is they've utilized this identity. Then we have the tan, and so remember we know that the tan is positive here in the third quadrant. So if by using the calculator we find that theta equals pi over 3, okay, and the whole 180 is pi, so then that means that we know that it will be in the first quadrant where we have pi over 3, and then taking the 180 from that pi over 3, we have 4 pi over 3, okay, or taking pi over 3 from the x-axis on the negative side, you can see that if we draw it clockwise, sorry, anti-clockwise, we will have this angle formed. Okay, and again the solutions are found by adding or subtracting the multiples of 360 degrees or 2 pi radians. So if we were not limited by these intervals, we could go round again, and round again. So just to use this example as a demonstration. So if we had 4 pi, so 0, and then we had 4 pi here, well then once we had pi over 3 and 4 pi over 3, we could then go over again, so we could have 7 pi over 3. Okay, so coming round again, we'd have here 7 pi over 3, and then coming round again we would have 11 pi over 3. Okay, so essentially it's arisen by 3 pi. So 7 pi over 3, sorry, and then 10 pi. Should have said 10 pi. Okay. And then we have exercises here for you to complete. And then this example is just demonstrating using a different sort of transformation. So in this equation here, you can see that you have cos 3 theta equals such between this interval. Now what has been asked of you to do is you can replace n theta plus alpha by x. So the equation reduces to the type you have solved in section 10.2. So you're using a substitution here just so that you can work it out in a neat manner without having to play around with division of any form or any sort. So you can say cos x degrees equals such, going through the whole working out and then reverting back to the original substitution to find the answer as intended by the question. So you can see that we have cos x degrees equals 0.766, and so since we have reduced the theta, we multiply it by 3 to correlate with our replacement. So we already know that it's 40 from our calculation here using the calculator, and then so we already know that we are dealing with cos, which is positive in the 4th quadrant. So we have 40, and then we go around once, okay, and then we're 40 shy of reaching 360, so we have 320. But then remember, for x, our interval has been multiplied by 3 to respect the fact that there's a 3 in front of our theta here. And so once we've done 40, 320, we add another 80, okay, and then we keep going round until we reach a value which is 180 or less. So you can see that these are all the points: 40, 320, 400, 680, 760, and 1040 or 1040. And then we revert back to using our original angles, which is 3 theta. And then since we are bounded by theta here, this interval 0 and 360, then we divide everything by 3. So we can see that these are all the points which satisfy this particular equation here, or this particular question here. And so solving this equation again, following a similar pattern, you can see that what's inside the brackets has been taken as the x, okay, and then once again they have rearranged the theta, the interval, okay, depending on what's inside the brackets. So you have the theta as originally stated, multiply it by 2 because of what's inside the brackets, and then you take it away by 35 because of the fact that it is here in the bracket. So it's a transformation of the intervals, shifting it to align with what we have here in the brackets, and then we try to figure out all the points that are between this interval. And so we say that x is minus 90 and 270, okay, and once we have that x is minus 90 and 270, again we have to then replace x with our original terms inside the brackets, and then just a simple rearrangement. So again, taking this to the other side, so adding 35 here and 35 here, and then dividing it by 2 to end up with this being theta. And just to outline where we got minus 90 and 270 from, well, it's just from observing the graph, you can see that it touches the point minus 1 on the y-axis. It matches the minus 1 point on the y-axis at minus 90 degrees and 270 degrees. And here are some examples for you to go through, some exercises. 10.4, you need to be able to solve a quadratic equation in sine theta or cos theta or tan theta. An equation like sine squared theta plus 2 sine theta minus 3 can be solved in the same way as x squared plus 2x minus 3 equals 0, with sine theta replacing x. So essentially this is a quadratic equation, solving it, okay, just with replacement of the terms. So as it's mentioned, is the x can be replaced with sine or any other trigonometric function here. So you can see they've done the following. So they've just simplified it by taking factorization, and then you can see that if this equals 0, we have cos theta equals as follows. Now if cos theta equals this, so we have 120 just by using our calculator, alright, and then you can see that this is the illustration that they have, and likewise you can see that it will also be equal to 240, and the reason is because 120 degrees makes an angle of 60 with the horizontal, okay, but cosine is negative in the second quadrant, but cosine is negative in the second and third quadrants, so we have 120 and 140, okay. So if you can appreciate that, we have 120 here, okay, and then we would have 240 again here. So we have 120, or theta equals 240. So theta equals 0 or 360. So we have 0, 120, 240, and 360. Okay. And you can see here that there are just some examples that you can go through with equations that are similar to what we had before with our x's. I'm just rearranging, factorizing, and finding a solution. Mixed exercises, which leads us to summary of key points. This chapter is particularly detailed and perhaps a little bit difficult to get your head around, so do go through it a number of times, watch the video enough times that you appreciate what's going on. I have a summary of key points here, once again just identifying the identities, and then here appreciating the solutions with regards to the different trigonometric functions. And if you understand that, then you should be halfway to appreciating the overall picture. So that's the end of C2. Thank you very much for listening, and join us again when we start our next module. Take care and goodbye.